Welcome to FOSDEM 2021. This talk is about secret management within the context of Kubernetes. You will not have many console or configuration outputs, but more an overview of what is currently available to manage your precious secrets with a Kubernetes platform. Unless you're watching a replay, note that you can interact with the audience and I during this talk using the chat feature. Quick intro about myself. You can call me Ron. That's going to be easier for everyone. I have been working within the storage industry for almost 10 years to make sure data are accessible and secure in all the different meanings of that last word. Then for the last 7 years, I've moved to a consulting role, helping customers with their automation and container journey. Why secret within Kubernetes? There are a couple of important key architecture points to take into consideration from a Kubernetes deployment perspective. And these needs to be addressed before and during implementation, and also later on when maintaining the platform. Those topics are linked to networking, storage, security, along the most important ones. Networking is mostly related to old legacy concerns and concepts, usually not applying anymore to Kubernetes, but creating useless extra layers of complexity within the infrastructure, unless you embrace a full software-defined networking. Storage is one struggle in many implementation because we need storage, right? Especially in the context of containers. Well, until you discover what it means to have a non-persistent data set in a container and the joy of the famous oops that goes before and after the question, where is the backup? The last bit is security, which can be anything and a real challenge to discuss with the security team, who most of the time is also victim of the old legacy governance. Well, speaking about security, let's zoom in on secret management. So, what is a secret? Well, from a generic definition, this is something that you don't want to share with anyone. And if you do, this is not a secret anymore. It just became a news that will spread around. Within the IT industry, this is a configuration element that could allow you to have access to a restricted resource like a database, an API service, or a device like a server. And this applies to Kubernetes also. One interesting element from a Kubernetes project standpoint is that the design reference for secret management is from 2017, referencing a set of options to handle secrets that did not really change so far. So how do I deal with secrets from a Kubernetes standpoint? Well, there's 3 different ways to do it. One would be to keep the password within the pods. Second one would be to use the internal Kubernetes secret resource management. And the last one would be to use an external solution. Let's have a look at those. So within containers, okay, so having a password in containers might be a solution that allows you to do some quick testing, quick hacking. However, this is not a secure approach nor a scalable one, considering that part of the deployment strategy would be to maintain current passwords for different services within containers, either from a deployment definition or worst, within the container image itself. Whatever how it would be done, this is a very dangerous path leading to disaster. I can share you a very interesting situation where a customer published a container image on Docker Hub with sensitive information related to their company. Remember the oops? Well, this is a big oops. The second way is to use the Kubernetes internals. Indeed, Kubernetes is offering an option to store secrets within etcd. This might sound quite appealing, considering that this is an onboard solution, being the closest to the workloads that would use secrets. This will also remove all the craziness of storing password with deployment configuration or within a container image. Although, there's a couple of things to know. First, the secret will not be encrypted. It will be encoded in base64, not really secure. By default, many Kubernetes distribution comes with an unencrypted etcd. Anyone with Kubernetes access can retrieve the secrets. Also, secrets will live within the target cluster on which you deployed that specific secret, and will not fit a multi-cluster scenario. So, is it a potential solution? Well, the answer to this question is still yes, if you consider the following recommendation. First, enable encryption at rest for etcd. Second, enable role-based access control rules, famous RBAC, to restrict reading and writing secrets on the platform. And last, a personal recommendation, do not store any secrets for external services like a database. The reason for the last personal recommendation is about containing a potential leak. If it will happen, it will only concern a very reduced set of data within a specific cluster that will definitely limit potential damages. Well, how does it look like? Well, creating secrets from a Kubernetes perspective can be done in multiple ways. One of them is by using a secret resource file and applying it via kubectl, kube control. This is what you can see on the screen on the left side. So we're using the command kubectl to generate the manifest for the secret. At that stage, we can apply that manifest to Kubernetes itself so that it's available for pods. On the left side, you have an overview of how to call the secrets that you just register from a pod perspective by using one of the methods, which is the environment variables that you can see here being secret underscore username and actually secret underscore password. So if you're thinking about GitOps, this would be a perfect example, except that you would save your secrets within Git, meaning that you just publish your secret in clear text or base64 encoded for anyone having access to your Git repository. Note that you can try this at home quite easily using Minikube, for example, or any other similar lightweight Kubernetes distribution. So the last one is about using an external solution. This option is about having a totally independent solution that would run outside or inside Kubernetes, or even in a hybrid mode. Such a decision will impact the actual availability of the solution towards single or multiple clusters, or even being used by non-Kubernetes workloads. Let's have a look at those solutions. From that list, which refer to HashiCorp Vault, CyberArk Conjure, Kiwis, Seal Secrets, and external secrets, I will have no look at the HashiCorp and CyberArk solution, as they have quite a good amount of collaterals being a product for enterprise purposes. However, I would like to give a shout out to two projects, being Seal Secret from Bitnami and External Secret from GoDaddy. I believe these are quite mature and interesting options when looking into an open source solution. Remember earlier when discussing about using a resource file to be saved within a Git repo, which was not a good idea actually, because the secret would be publicly available and in clear or base64 encoded text? Well, this is where Seal Secret from Bitnami embraces the GitHub concept and solve the clear text issue. Sealed secret is based on the client-server approach, having a controller deployed within the Kubernetes cluster, and having a CLI tool called kubectl on the client side. It introduces a one-way encrypted secret that can be created by anyone, but can only be decrypted by the controller running on the Kubernetes cluster. This is based on the principle of public key cryptography involving a public and a private key. Let's have a look at it. So nothing too much different considering the previous example. On the left side, we have exactly the same, the manifest, the creation of the manifest, and then we introduce the kubectl, which will check on the controller running on the Kubernetes platform for the certificate and encrypt the data. When the data is encrypted, then we can apply that manifest towards the cluster. And at that stage, we have the output from the encrypted payload, which is on the right side. Not too much different than what we have on the left side, except that this time it's not base 64 anymore. It's a real encryption. The last approach is to use external secret from GoDaddy. It provides an API extension to Kubernetes by adding the concept of external secrets from an API perspective, using custom resource definition along with an embedded controller within the Kubernetes cluster, a bit like the sealed secret. Assuming that one KMS is available internally, the idea is to leverage that existing KMS within your infrastructure instead of reinventing the wheel. Doing so will avoid to retrieve secrets and exposing them to the world during the processing time to make them available within the Kubernetes cluster. A controller is deployed within the Kubernetes cluster and will handle requests from pods to get secrets using the Kubernetes API. The controller will fetch the secrets from the KMS to safely store them within the Kubernetes cluster and will decrypt them and expose them to the pods on demand. So pretty good solution so far, those two open source projects. But let's summarize what we discussed about with some food for thoughts. First thing is to understand the options to deal with secrets and how secrets works from a Kubernetes resource management standpoint. Then try to answer the questions about what is already available in your infrastructure and your commitment to a cloud native development using DevOps concepts like GitOps or infrastructure as a code. A last question that comes in mind when looking at the existing solution is why there is not much love to secret management, considering the design document dating from 2017. And finally, for everything you're trying to do in your infrastructure, just apply the KISS principle. Keep it simple and a bit stupid at the end. Thank you for watching, and have a good FOSDEM 2021.
Hi everyone. So to answer Adil, I never used it. So usually KMS are a pretty good solution because it really gives you the opportunity to have a real solution to secure your secrets. And then it's depending if there's already some modules available from a uh, Kubernetes perspective or container perspective to have a sidecar, for example, to fetch the secrets, that would be perfect. It looks like it is a cloud native, that the solution you're mentioning. So I would expect indeed a sidecar for this. I'm quite interested about it, and I will look into this definitely. Oh, Arnaud, this is a pretty good question. So not that much people actually. This is something that we don't see much from a CI/CD workflow perspective. I was mentioning putting in production field secret. That's the only time I have seen it, and that was scary for the customer from a security standpoint at some point. But at the end of the day, it really is the concept of ephemeral password for a service, because they could not just have a well-known password that exists for years, but renew that password at the time of the deployment and deploy that password on the different instances, so that each time you deploy a new version of the application or